Okay, so honestly, this is one of the dumbest questions possible, and it's so annoying because nobody can wrap their head around it. But you have to start with sort of an XY graph. So just start there. So X would be the number of processors, and Y would be the yield. You can see that when there's 24 processors, there's 300 qubits of yield. So let's start with that. And they tell us when I add a processor, we get 5 less qubits. So we can keep going. To add a processor, 5 less qubits. We can see that this is a linear relationship. It's going down by 5 for every X unit that's going up. Now you could have two choices. You can figure out when X is 0 and figure out that way and just do a Y is equal to MXB, because it's clear that M is equal to minus 5 here. It's going down by 5 for each X unit. So it's going down by 5Y by each one X unit. And you could do a Y is equal to MX plus B if you knew what B was. We don't really know what B is, but we have a minus 5. Fortunately, we do have a an X and a Y. We can use any X and any Y. So let's use our 300 Y when X is 24. 5 times 24, negative 5 times 24 is negative 120, which means B is equal to 420. So really we have this formula. Y is equal to negative 5x plus 420. And that should give us any value of x. So when x is 0 here, our yield is 420. So that's our y-intercept. And if we were to plug any of these numbers in, it would work. So that's our first equation, when we have this relationship between our qubits and our yield. But then they want to know the maximum qubits. When is our maximum qubits? Well, the maximum qubits is going to come about when we take our number of processors, and we multiply it by our qubits per processor. Qubits per processor. So let's see if I can fix that. Times qubits per processor, and the word processor will cancel out and leave just qubits. Well, this is our value of P. And this is technically qubits per processor is, well, let's just call it X. And our qubits per processor is our Y. Y can be replaced with this. And if we expand it, we get minus 5x squared plus 420x. So this is clearly an an upward facing, minus 5x squared. It's a downward facing parabola, so it's going to have a maximum. So we're going to take the derivative of that. Plus 420x, so it's plus 420. And we're going to set that to equal to 0. We're going to subtract 420 from both sides. And we're going to divide by minus 10. That means our maximum yield occurs when x is equal to 42. So that means it takes 42 processors to have a maximum yield. Now, to confirm these answers, the best thing you can do is to take your decimals and write in your formula minus 5x plus 420x and find your, so apparently 42 is going to be where it happens, somewhere over there. So that means you've got to sort of make your x go from, let's say, minus 5 to 122, and we're going to make our y way up high, like 1,000. Even more, just to see the top. Again, we're going to see our x to 444, something like that. Oh, I forgot to put x squared. And sure enough, if we zoom in on this, we discover when x is equal to 42, we find a maximum yield of 8,820 qubits. And you might say, well, why was it, why was the yield, why would our maximum qubits be high if our production was going down? Well, you still hit a point where even though your output is getting smaller, the more units you have, you're going to hit a max. And then eventually that's going to topple over and work against you. A lot of companies' maximum profit works this way because, for instance, if your cost of overhead of employing people exceeds your profit margin, you start to hit this downward slope where you're paying people salary and you're not maximizing your profit. Sometimes making fewer products with fewer people yields you a bigger profit. Businesses do this all the time with drug prices in the States, where they make more money selling 42 drugs at $8,820 than they would selling 80 drugs at a smaller price. So not only do they have to produce fewer drugs, they get a better result. And that's where you see these crazy prices in the States, because in the States it's a free market. So that's that stupid question, which I don't really like because it's nonsensical. Now this one's a weird question. They often put one side of it that isn't part of the fencing. In this case, there's a river on this side, and then they put a fence around Gotham Wayne Manor, so a Batman reference. But for some reason, this fence over here is cheaper. It's 4 times the length here. And this fence down here is $12 per meter. It's much more expensive. So if you notice, our total cost is equal to 3,600. Well, that means if this side is X and this side is Y, the formula is going to be $4 for each X and $12 for each Y. But then on the other side, we have another X. So it's another 4X on the other side plus 12Y. So this is ultimately the equation. That's because each X here costs $4 per X, and each X here costs $4 of X, so we have to do 2 of them. But then this 12Y is just once. So we're left with 8X is equal to that. So that's our first formula. Great. Then they're trying to maximize the area. Well, the area here is going to be our max area. There's always 2 formulas. Our max area is going to be X times Y. And as I always said, you're pretty much replacing one of these, usually Y, with a value, the easiest value that you can. But we're going to take this one up here. We're just going to get rid of the visual now. And we're going to isolate Y. So it's 12Y is equal to 3,600 minus 8X. And then we're going to divide both sides by 12. So you get 3,600 divided by 12 is 300. And then this 8x over 12 can be simplified to minus 2x over 3. That's a linear relationship. And that just means I'm going to replace my y down here with that. And it's important to put it in the brackets. When I expand it, I get this. My max value is going to, I'm going to use this formula and just keep the primitive equation around because it's going to be easier to use that later. The max is equal to 300x minus 2x squared over 3. So that's the same as this. Great. Now we just take the derivative of this. The 2 comes down in front times the minus 4, so you get minus 4x over 3. And the derivative of this is just 300. That's the derivative of that. You set it equal to 0. You put the 300 on this side. Or actually, let's just put the 4x plus 3 on this side. multiply both sides by 3. Divide both sides by 4. So that divided by 4 is 450, and then that divided by 4 is 225. You get x is equal to 225. That means, going back to our formula, our length of x should be 225. And if we look at that and we put it back up here, we can say, okay, well, if 225 is x here, we have 8 times 225. Did I get that right, by the way? Let me just make sure. 900 divided by 4, 450, 225. So that means 8 times 225 plus 12y. I'm just solving for y now. It's going to be equal to that. I have to find 8 times 225. 1800. Subtract 1800 from both sides. You get 12y is equal to 1800. And you're just going to divide that by 12. That means our y is 150. So x is 225 and y is 150. Going back, make sure you answer the question. Find the dimensions of the maximum area. Okay. That means we have a wall here, long wall here. Actually going to be short. And a long wall here. It's actually going to be shorter than the long wall. It's going to look more like that. So you're going to have 225, 150 here, and 225. And again, to make sure you got the things right, you would put your parabola, which is there. You can just use it. You don't even have to expand the parabola. You can use this. It's y is equal to x times 300 minus 2x over, I think it was over 3. Then you can look at your image and make sure that when x is 225, we hit max. Enough when x is 225, we hit the max, which gives us x, and then we got to go back and figure out y. I just want to point out that you can isolate x if you want and put x into this equation instead of y, and you will still get the same answer. Okay, this one's straightforward now. I used to just solve it quickly like this. So if you look at our profit is base car times the charge. And right now they have 54,000 cars, and they charge 50 cents per car, so they make 27,000. The new profit would simply be the old number of cars. So they're saying for every 5 cents increase in price, we would have a decrease of 500 cars going across the bridge. What's the max profit? Well, you take the original number of cars, and for every time you increase the price called X, we have to subtract 500 cars. But we also would take 50 cents and we would add 0.05 times X each time to figure it out. Now that's just my logical way of doing profit. Now let's just quickly, now don't panic because you're like, how did you come up with that? Let's look at what that's going to look like. It's going to be a parabola because it's x squared, right? So we're going to just put it in as it is, rough. Just see if we're right. 54,000 minus 500x times 0.5 plus 0.5x. So each time we increase the price, we decrease the cars. And we can see that we should get an answer 49. So 49x. So we should increase it 49 times, and we'd have to figure out the new price and the new number of cars, depending what they're asking. What 49 times 0.5 cents. So let's see what that is. 0.05 times 49 plus 0.5. Our new price to maximize profit should be $2.95, and it will greatly reduce the number of cars going over the bridge too.